Hello viewers, we discuss today the linear equations with constant coefficient and many interesting cases. Linear equations with constant coefficients, and it's an important topic in differential equations, and there are the two several parts we discussed today: complementary functions and particular integrals. Suppose we are studying what D operator. D operator actually means, that's D is nothing but something like that, ddx. It's clear already. And if we say D of sin x, what will be our result? It's clear that cos x. And now if we are taking this D operator as a differential operator, and if we say it's integral operator, what will happen? That is D inverse. What will happen with? In that prospect, this D inverse is equivalent to some integral operator. It's a general technical basis, I discuss it, and in which respect that is some dx or whatever may be dt. As we choose here, it is arbitrary because we are taking here y is the function of x, something like that, that is dx dt. It's arbitrarily we take it in this manner. And if we say d inverse operated with x, what will happen here? That is integral of x dx. This will our result, and general definition of integral, that is half of x square. But in these cases, in particular integral, we already neglected constant. And if we are taking like this d inverse of cos x, on the other hand, we can get back the result sin x. So it is the inverse functions, and already we have the property, that is this d inverse is identity element. That's one unit identity, better to say. So d inverse represent inverse of this. So differentiation is also inverse of integration, and inverse of integration is also differentiation. Now it is a technical, all technical things we require to do. Now let's come to the main point: complementary functions and particular integral. For our basic knowledge in senior secondary level, we know few ideas about the complementary functions, but we don't know that curriculum what particular integral is. But today we start with the particular integral. Let's watch till the end. And who are watching this video first time, they are advised to subscribe the channel at first and press the bell icon to get all of my latest update. Let's watch. To understand particular integral easily, let's start with a problem. Suppose 1 by d plus 1 is operated with x square plus 1. How to solve this problem? Easily we have to find it. At first, in these cases we can take in this way, like this, d 1 by d plus 1 of x square and 1 by d plus 1 operated with 1, and separately we can find these two results. If we are taking as a point of u plus v, where if we take 1 by d plus 1 with x square as u and 1 by d plus 1 this as v, then how to find? Actually, how to find this type of operator? And we consider the first expression, 1 by d plus 1 of x square is equal to u. That is, this d plus 1 will be there, that is 1 by d plus 1 of u operated with u makes x square, which imply if we are taking d in the form of ddx, so ddx plus 1, that means du dx operated with u, du dx plus u is equal to x square. It is a linear form, and if we are taking integrating factor, elementary idea, that is 1, u is the function, so here we take function of px plus q, form of dy dx plus px plus q in this form. So here its form is constant, so 1 is there. So if integrating factor if is equal to e to the power 1 dx here. So it's clear that's e to the power x. And if we multiplying this, therefore e to the power x dx du dx plus e to the power x u is equal to x square e to the power x, and it will convert it to ddx of u into e to the power x, that will be x square into e to the power x, and integrating we obtain, so after integration it will be u into e to the power x, that will be integral of x square e to the power x dx, and it is a by parts method of by parts, ILATE. So first function into integral of the second, and first function is x square into integral of the second minus derivative of the first, that is 2x into e to the power x dx, and we have needed by parts once more for integral x e to the power x dx, and this result will be e to the power x into x square minus 2, again by parts, so x e to the power x minus e to the power x. It's clear. First function derivative of the second, so x into integral e to the power x, that is e to the power x minus derivative of the first, ddx of x is 1, integral e to the power x is e to the power x, and we don't write here any constant term. So finally we write u e to the power x is equal to u e to the power x equals to x square e to the power x minus 2 into, and if we are taking, that's u is equal to x square minus 2x plus 2, no constant involved in these cases, and therefore we finally find u, and now 1 by d plus 1 operated with 1, if we taking as v, that is operated with v, that is 1 d plus 1 with v, which imply dv dx plus v is equal to 1. So here also if integrating factor, similar situation, if e to the power dx, that is e to the power x, multiplying both sides, e to the power x dv dx plus v to the power x equals to e to the power x, that is ddx of v to the power x, that is equal to e to the power x, integrating v to the power x equals to e to the power x, that is v is equal to 1. So finally we find v equals to 1, and therefore 1 by d plus 1 equals to x square plus y square is equal to, we take in this form of 1 by d plus 1 x square plus 1 by d plus 1 1, that is u plus v is equal to, finally we write x square minus 2x plus 2 plus 1, that is x square minus 2x plus 3. So in this way we solve this type of problem. Why we discuss this problem? To clear the idea how the operator works. It's the basic definitions and basic problems. We start with this problem to clear this idea. In next videos I will produce and demonstrate many other examples to clear this problem, to tackle it more efficiently and effectively. And the students are advised to follow all these type of videos to get clear ideas of linear equations with constant coefficient and d operator, which is absolutely useful in many ideas and helpful in many ideas in physics, especially part of mechanics, and in many areas of applied mathematics and physics. Let's watch and keep watching my videos and our discussions here. And once more, I request all the students who are watching this to subscribe the channel and press the bell icon. Thank you.